Right now, the ground that Alaska has stood on for 20,000 years is liquefying. Overnight, entire cliff faces the size of city blocks are peeling away from the coastline and crashing into the sea. Villages that existed on maps last year are gone, swallowed by a shoreline that is retreating so fast that geologists cannot measure it quickly enough to keep up. Beneath the surface of the water where those cliffs are falling, something is building that scientists describe in private with one word: unsurvivable. Alaska's coastline was never built on rock. It was built on ice. Frozen soil, frozen sediment, frozen organic material compacted over 20,000 years into a substance so dense and so stable that entire mountain faces, entire coastal bluffs, entire communities were constructed directly on top of it without question. That substance is permafrost. And right now, it is thawing. Permafrost is not simply frozen dirt. It is the structural skeleton of the Alaskan coast. Interlocked ice crystals bind soil particles together with a grip that rivals concrete. Coastal bluffs along the Beaufort Sea and the Chukchi Sea stand 60, 80, 100 feet tall, held vertical for millennia by nothing but frozen water running through them like rebar through cement. Remove the ice, and the bluff does not weaken gradually. It does not erode slowly over decades. It collapses. Suddenly, catastrophically, and with no warning. Alaska is warming at 4 times the global average rate. The numbers are not projections. They are measurements. Permafrost that has remained continuously frozen since the last ice age is now thawing at depths that scientists did not expect to see compromised for another century. The thermal models are obsolete. The acceleration has thrown every geological projection out the window. The coastline is responding in ways that have researchers at the United States Geological Survey describing the situation with language they do not typically use in published reports. On September 14th at 6:51 in the morning, a coastal monitoring buoy operated by the National Oceanic and Atmospheric Administration registers an anomalous pressure wave off the Kenai Peninsula. The reading is small and easily dismissed. A technician flags it and moves on. 4 hours later, a second station 112 miles to the southwest detects identical signatures. By early afternoon, aerial survey teams dispatched from Anchorage reach the source coordinates and find something that stops them mid-transmission. A coastal bluff measuring approximately 800 feet across and 120 feet tall has sheared completely away from the Alaska Peninsula and dropped into the Gulf of Alaska. Not eroded, not crumbled at the edges. Sheared. The entire face gone in a single event, leaving a raw vertical wound in the earth that exposes dark, unfrozen sediment still steaming in the cold, salt air. The material beneath the bluff had been thawing silently for months, invisible from the surface. When the frozen cap above it finally lost structural integrity, the collapse was instantaneous. This was not the first event. United States Geological Survey records document coastal erosion rates along Alaska's Beaufort Sea coastline, accelerating from an average of 6 feet per year in the 1960s to over 35 feet per year in recent measurements. Some individual sites are losing over 100 feet of coastline annually. Monitoring stations installed along the Alaska Peninsula are now detecting micro-seismic signals, the actual acoustic signature of frozen soil fracturing, at frequencies that have increased 43% over the past 36 months. Scientists are not watching this coast erode. They are watching it disintegrate. Here is what is not making the news. Here is what the coastal erosion reports and the climate briefings are not connecting out loud. Above Prince William Sound, above the Gulf of Alaska,